Welcome guys to this solution video, March 2022 additional math paper 1-2. Question number 1 says find the values of k such that the line this does not meet the curve this. Alright, so we start by assuming that they do meet. Okay, if they meet, this is the curve, this is the line, they will have somewhere point of intersection. Let's try to find out if they had some point of intersection. So since the y coordinate, see this is the y, suppose this is x-axis, so this will be the y coordinate. At this point, the y coordinate of this line and this curve are equal. So we can make that this y is equal to this y. Let's equate the two. 9kx plus 1 equal to kx square plus 3x 2k plus 1 plus 4. Okay, let's collect everything to the right side. So nothing is left on the left side. This 9k and plus 1 come to the right side. Minus 9kx minus 1 plus kx square plus, let's open this bracket. It becomes 6kx and 3x times 1 is 3x plus 4. Let's give it a shape of a quadratic equation. Kx square. Okay, 6kx and minus 9kx will be minus 3kx plus 3x, this one, and minus 1 plus 4 will be plus 3. So let's take this x common to make it a quadratic equation in a perfect shape. So there's a negative here, but we will write plus. So I will write 3 first. What I'm planning, I will write x later so that it becomes a quadratic equation. So because 3 is positive, I will write 3 first and then minus 3k because it's negative. Plus 3. Now it is a perfect quadratic equation, and we assumed at the starting that they do meet. Okay, they intersect, but now we want that they do not meet at all. That means this quadratic equation has no real roots. That's what we are assuming now. For that, we know that discriminant b square minus 4ac has to be negative, less than 0, so that they don't have any real roots. So in this case, this is our b, this is our a, and this is c. So we will substitute them now. 3 minus 3k square minus 4 times a, which is k in this case, and c is 3, is less than 0. So to make it a perfect quadratic inequality now, we'll have to expand this one. So for that, we have an identity a minus b whole square is a square plus b square minus 2ab, and that's what we will apply here. A square plus b square minus 2ab, and what does this become? 4 times 3 is 12k, and should be less than 0. Alright, 9 plus 9k square, and this becomes 3 times 3, 9 times 2, 18 minus 18k minus 12k is less than 0. And let's finish it here. 9k square is the first term for a quadratic inequality, then minus 18 minus 12 minus 30k plus 9 is less than 0. They are too complicated. Let's divide all of them by 3 so that it becomes easier. We can do that, right? Each term divided by the same number. 3k square minus 10k plus 3 is less than 0. Now, since it is an inequality, we can't have one answer. We'll have a range of answers. So what will we do? Let's factor these to get the roots first. So for roots, or critical points, sometimes people call them, we will factor this. So you can use your calculator also to get roots straight away enter this as A, minus 10 as B, and 3 as C. But I'm factoring it. 3k square minus 9k minus k plus 3. So 3k is common here, k minus 3 minus 1, and 3k minus 1, k minus 3 is less than 0. Now this is for roots. Most of the people, what do? They treat it just like an equation, and they say this is less than 0, 3k is less than 0, and k minus 3 is less than 0, which is wrong. It's a mathematical crime to do this. Never do that. What should we do? Because it is for roots we have done, just make them equal to 0 1 by 1, and we'll get the roots. 3k minus 1 equal to 0, k equal to 1 over 3, k minus 3 equal to 0, k equal to 3. These are the roots. Okay. Next step for you should be that put those roots on a number line. So this is 1 over 3 and this is 3. 1 over 3 is smaller, 3 is bigger, so they are on this way. So our answers will be in these three sections, either here or here or here. And now to choose a perfect answer, take a number less than 1/3. Okay, less than 1/3, let's say 0. 0 is the best. Put 0 in our inequality. What was the inequality? This was the inequality, right? Put 0 here. 3 times 0 is 0 minus 1. 0 minus 3 is minus 3, less than 0. Minus 3 is 3 less than 0. It's an incorrect statement, right? That means this is not your answer. Any number less than 1/3 is not your answer. Now take a number between 1/3 and 3. Let's take 1. Okay, so let's substitute this k by 1. So it becomes 3 minus 1, 2, and 1 minus 3 is minus 2. Is minus 4 less than 0? Yes, it is. So this is your answer. Obviously, if you put a number more than 3, maybe 4, 5, 6, even 100 if you want, you will definitely get a wrong statement like the first one. I'm not doing it. You can do it yourself. I'm leaving it to you. So this is your final answer. From 1/3 to 3 is your final value for k. 1/3 to third is the solution for this equation, inequality rather. And I'm not writing any equal sign here because the inequality I had here, this inequality rather, this one, did not have any equal sign, so I will not put any equal sign here. This is the solution. Okay, we can see there is a second question here. Do not use calculator. I usually do not use calculators in my solutions, but here they have categorically said that there should not be any sign that you use your calculator. Okay, solve the equation. Exactly similar case. Yeah, but this is in Surds and it's an equation, and we can use quadratic formula to solve this quadratic equation. This is the formula, correct? So let's say this is A, this is B, and this minus 1 with the sign is C. So let me substitute patiently. Always be patient with surds. One small mistake and you get wrong answer. Okay, so minus B, 2 square root 3 plus 5 plus minus square root B square, 2 square root 3 plus 5 again, square minus 4 times A. And when we do this in exam scenarios, sometimes we get scared. Oh, it's becoming so complicated. Let me assure you, rather guarantee to you, that this will become very simple. Most of the terms will get cancelled out. So never get scared by the look of what you see in front of you. Okay, so it has so many surds, a square inside, but no, everything will get cancelled out. I'm sure about this. Okay, so minus, let's not open the bracket yet. I will open it later to make it cleaner. Leave it like this, plus minus. Okay, next thing is to square this one, and this time I will use the identity a plus b whole square. So it is just like the previous one, but the last term is plus 2ab, and that's what I'm going to do here. So 2 square root 3 square plus 5 square minus, rather plus 2 times 2 square root 3 5 opened. This bracket is opened. Now we will open this one. Minus 4 times 3 is minus 12. Minus 4 times minus 5 is positive 20, and there is a square root 3 also. And this minus is multiplying with this whole bracket and minus 4. That means it will make this bracket positive. So this becomes, rather, let me redo this. Now to expand this one, we will multiply minus 4 and minus 1 first, so that they become positive 4. So this is gone. I can treat this as positive 4. Positive 4 times 3 is positive 12. And 4 times minus 5 square root 3 minus 20 square root 3. We are not using any calculator, mind it. Okay. In that case, you have to use every step, every detailed step you should show to prove that you didn't use any calculator. Now look here, I did not open this one. 2 times 3 minus 5 square root. I did not open this because this 2 surely is going to get cancelled out. That is my experience, and this happens most of the times. So let's not open it. Never open the denominator. Okay. So let's keep it still inside bracket. 2 square root 3 plus 5 plus minus square root. Okay. Square of this will be 2 square and square root 3 square. 2 square is 4. Square root 3 square is complete 3. Yeah, let me explain here. 2 square root 3 square will be 2 square square root 3 square. Whenever two terms multiply, the exponent on them is applied to both of them. So it becomes 4 times 3, which is 12. So 12. 5 square is 25. And this is plus 2 times 2, 4 times 5 is 20. Square root 3 plus 12 minus 20 square root 3. See, we have plus 20 square root 3 minus 20 square root 3 gone. Over 2, 3 minus 5 square root 3. So now minus 2 square root 3 plus 5 plus minus square root 12 plus 25 is 37 plus 10 49, a perfect square again. 2 3 minus 5 square root 3. So this gives us two options now. We'll separate this plus and minus. Okay, two roots. So now open the bracket. Minus 2 square root 3 minus 5, and I'll take the positive one first. Positive 7. Square root of 49 is 7 over 2 3 minus 5 square root 3. Down there, minus 2 square root 3 minus 5 minus 7 over 2 3 minus 5 square root 3. Okay, so this becomes, let's take the advantage of this space, minus 2 square root 3 plus 2 over 2 3 minus 5 square root 3. See, I was telling you this 2 will get cancelled out with the 2 on top. This has 2, this has 2, this has 2. There's a plus here, that's why the 1 down there should cancel out with everyone. So this 2 cancels with this 2, and this 2 in place of this we have 1 here. So let's write the positive one first. So it becomes 1 minus square root 3 over 3 minus 5 square root 3. We'll take care of this later. Let's simplify this one also. It will be minus 2 square root 3 minus 12 over 2 3 minus 5 square root 3. I'm cancelling this 2 because it's multiplying with the rest of it. So no need to look inside because it's anything multiplying can be cancelled. But anything that is adding should be with each one. So it is minus 2 cancelled out, but this will become minus 6 cancelled by this 2. So let's write the 6. No, both of them are negative now. So minus square root 3 minus 6 over 3 minus 5 square root 3. Now let's look at our question. They said giving your solutions in the form of a plus b square root 3, and that's what we should do. So let's convert this one first. 1 minus, so solution 1 is 1 minus square root 3 minus 5 square root 3. Be very careful at every stage. I'm reminding you again. Surds, people think them to be difficult just because they do not take care while copying things. Okay, so now I have to multiply these numerator with numerator, denominator. I hope you understand what I did. I multiplied this particular rational expression with the conjugate of the denominator, because in if you see, they have said a plus b square root 3, there is no denominator in surd form, so there must not be any surd at the bottom. Okay, so let's multiply 1 with 3, we get 3. 1 with 5 square root 3, 5 square root 3, minus 3 with 3, minus 3 square root 3, minus square root 3 with this, square root 3 and square root 3 will become a complete 3, so it will be minus 15 over. Now we have another identity, a plus b, a minus b. If they are multiplying, earlier identities we had squares, but here they are different, plus and minus, they are equal to a square minus b square. This is the expansion. If you want to expand them one by one, you can do that, but that will not look professional. Okay, so you can just use these. So it will be 3 square, which is 9, minus 5 square root 3 square. Okay, so 3 plus minus 15 is minus 12. 5 square root 3 minus 3 square root 3 is 2 square root 3. Okay, and this becomes 9 minus 5 square is 25, just like the way we did earlier, and square root 3 square will be complete 3. So it becomes minus 12 plus 2 square root 3 over 9 minus 75 minus 66. So let's simplify this further. Since all of them have 2, so we can cancel this out. Minus 33 minus 6 and 2 is gone. So if we separate the numerators, it will become minus. Let's move on to the second one, which was minus square root 3 minus 6 over 3 minus 5 square root 3. This one, second one. We'll again rationalize the denominator by 3 plus 5 square root 3, 3 plus 5 square root 3. So minus square root 3 times 3 is minus 3 square root 3, minus 3 times 5 root 3 will be 5 times complete 3 again, because square root 3 times square root 3 is complete 3. Minus 6 times 3, minus 18. Minus 6 times this will be minus 30 square root 3 over, again same identity, a plus b, a minus b will be 3 square minus 5 square root 3 square. So we have 3 is minus 3 square root 3, so it will become minus 33 square root 3. Minus 15 minus 18 is minus 33. Alright, 3 square is 9 minus 75 again. 5 square times square root 3 square is 75. And this becomes minus 33 square root 3 minus 33 over negative 66. And yes, we can cancel again by separating the two numerators with single denominator. So this negative cancels with this negative. 33 times 2 is 66. 33 times 2 is 66. Negative and negative cancel again. So we get half square root 3 plus half, or you can interchange their places. This is the second solution in the format they wanted. Some of you may be remembering, thinking that they are denominators again, but they are integers. They are not surds, and that's why they are acceptable. Question 3. The curve with equation this, where ABC are constants, passes through these 2 points. Okay. It is given that this A sine bx, exactly, same one, has a period of 16 pi. What is the value of A, B, and C? That's what they're asking. Okay, so straight away we can find the value of B first. Okay, the question is y equal to A sine bx plus C. B is the coefficient of x, and period is always 2 pi. Is it in terms of pi? Yes. 2 pi divided by the coefficient of x in angle. Okay, so we have B here. So period is 16 pi is equal to 2 pi divided by B. So we can carry out cross multiplication here. B will go and replace 16 pi. 16 pi will take B's place. That's how cross multiply helps. So B equal to 2 pi over 16 pi. Pi and pi cancel. 2 over 18 will be 1 over 8. This is the value of B. Now we have to find the value of A and C. So let's substitute this point, first point, 4 pi 11 in this equation. So 11, y is 11, A is unknown, sine B is known now, 1 over 8. X in this point is 4 pi plus C. So 8 and 4 pi will cancel out, rather only 4 will cancel out, so we'll be left with 2 here. So 11 equal to A sine pi by 2 plus C. Sine pi by 2 is 1. So 11 equal to A plus C, because this is 1, 1 times A is A. This is equation number 1. Now let's substitute the second point. Here the y is 5 equal to A sine and 1 over 8 times minus 4 pi over 3 plus C. 4 and 8 cancel again. So 5 equal to A sine minus pi over 6, yeah, 2 times 3, 6 plus C. Now to find the value of this, you can use your calculator or use simply logic. Minus pi by 6 will be in fourth quadrant, right? This direction, and in this direction sign is negative. So whatever is sine pi, just put a negative in front of it. Sine pi by 6, sine pi by 6 rather, huh? Sine pi by 6 is half. So 5 equal to minus 0.5 A plus C. Yeah, 0.5, because this is negative 0.5, I put negative 0.5 in front. This is equation number 2. So let's use the elimination method to find the value of one of them. So let me put this equation under this first equation, equal to minus 0.5A plus C. Subtract the second equation from the first equation. The minus 0.5 changes to positive and others to negative. They cancel out. 11 minus 5 is 6 equal to 1.5A, and that gives us A equal to 6 over 1.5 which is 4. And now let's use this equation to find the value of c. Minus 0.5 times 4 plus c. So c stays here, and minus 0.5 times 4 will be minus 2, but when we bring it with 5 it becomes plus 2. So c is 7. 5 plus 2, 7. A is 4, c is 7. Let's see what next. Using your answer in part A, find the coordinates of the minimum point on the curve for 0 to 16 pi. Okay. So our equation now becomes y equal to a. A we got as 4 sine 1 over 8x plus 7c, right? This is the equation. We have to find its minimum point and its coordinates. One way is that we differentiate this and then make it equal to 0, find the stationary point, which will be a long because it is up to 16 pi. The easier way will be draw its graph. The period is 16 pi, right? And half of 16 pi will be 8 pi. Half of 8 pi will be 12 pi. Half of 8 pi is 4 pi. And 3 times 4 is 12. It should be in sequence 4, 8, 12 and 16 pi's. And we can draw the graph of this whole thing here. Okay, this is the challenging part, and then we'll get the minimum point very easily. First of all, we should mark the 7 axis. So let's say that 7 is here. Okay, so this is axis. Now 4 is the amplitude, that means 4 above this, which is 11, will be the maximum. And 4 below 7, which is 3, somewhere here, will be minimum. Our graph will be between these 3 lines. Our sine graph, normal sine graph, looks like this, correct? Starts from axis. So let me start this from axis 7. That at 4 pi it should reach at the maximum, which is here. Then it should reach at axis again at next 1/4. Then it reaches a minimum and then the maximum again. So this is the graph of this function. Okay, and we can see that the minimum is here. And what are the coordinates of minimum? X is 12 pi and minimum is 3 pi, y value is 3 pi. These are the coordinates. Okay, next one. Show that this equation, rather it is just an expression, can be written as this. Okay, so let me copy this first. 1 over 2x minus 1 plus 4 over 2x minus 1 square. Multiply this by 2x minus 1 extra y, because we want a square here also, so we have to compensate it, the numerator as well. So multiply up and down by the same expression, you effectively multiply by 1, which is okay. So now both of them have same denominator, 2x minus 1. Since they have same denominator, we can merge the numerators. So 1 times 2x minus 1 is this, and plus 4 is alone. So we get what they want, 2x plus 3 over 2x minus 1 square, and done. I don't know how many marks were this, I did not copy that. Anyways, find the integration of this from 2 to 5. Is it exactly same? Yes, it is 2x plus 3, 2x minus 1. Yes, so no change. That means we, in place of the question, we can write the integration of this one. So let me write here only 1 over 2x minus 1 from 0 to how much? 2 to 5. 2 to 5 dx plus, let's write 4 outside, 1 over 2x minus 1 square dx. So in place of this, I wrote this because they are equivalent. Okay, so the integration of 1 over a linear denominator is very easy. We can write natural log and 2x minus 1, whatever is the denominator, but we have to divide by the differentiation of that denominator. Differentiation of 2x minus 1 is just 2. Okay, plus 4. Okay, this one can be written as 2x minus 1 to the power minus 2. And when we integrate this, it becomes 2x minus 1 to the power minus 2 plus 1 divided by minus 2 plus 1. And further, we have to multiply the denominator by the differentiation of what is inside the bracket. Yeah, actually, we are dividing it by the differentiation of the contents of the bracket, which is 2. 2 is the differentiation of 2x minus 1. So let's write it here. 2x minus 1 to the power minus 2 plus 1 is minus 1 divided by minus 2 plus 1 is minus 1 and minus 1 times 2 is minus 2 plus c, and let's simplify it further. So it will be ln 2x minus 1 over 2 and minus, this minus will make this positive as minus and 2 and 4 cancel. 2 divided by this because it's a negative exponent it is having, so I'll make it a denominator, makes it positive, plus c. And from 2 to 5 again. Let's substitute the limits of the definite integral 2 and 5. So ln 2 times 5 is 10. 10 minus 1 is 9 over 2 minus 2 over 9 again plus c minus ln 2 times 2 is 4. 4 minus 1 is 3 divided by whole 2 minus 2 over 3 plus c. C and c cancel out, and now we have to simplify this one. Let's write half ln 9 minus 2 ninth minus half ln 3 minus 2 third. If you can see here, this is the format we want, a plus ln b. So that means this ln must not have any coefficient. This half should go up there. So first let's take half common out of these two lns, and they become natural log 9 minus natural log 3. These two half taken common, and we are left with minus 2 ninth minus 2 third. So since two logs are subtracting, we can divide the contents now by making them one log. 9 over 3. Both of them are negative. Are you sure they are negative? No. This 2 third will be positive. Yes. So we'll multiply this by 3, multiply this by 3. So that they have same denominator. So minus 2 ninth plus 6 ninth. Yeah. We don't want any coefficient, so this half goes and becomes coefficient by laws of logarithm. So ln 9 over 3 is 3 to the power half plus 4 ninth. Yeah. 2 maximum, yes. So what is the format now? 4 ninth plus ln square root 3. They're saying exact form, they're not saying, but let's leave it like this. So this becomes your a, 4 over 9, b is square root 3. Question 5. Variables x and y are such that y is equal to this. That's the equation of the function. Find dy dx. That means they are asking us to differentiate this. So we can use quotient rule because it's a rational function. All right. For quotient rule, we have to square the denominator first. So dy over dx equal to, write the same denominator first and differentiate the numerator ln 2x square minus 3, subtract this times, differentiate the denominator but write the numerator as it is. Alright, so let's continue here. Square of 3x will be 9x square. 3x remains 3x. Differentiate ln this. Whenever you have natural log, its differentiation is 1 over whatever that is. 2x square minus 3 multiplied by the differentiation of what was inside the bracket of the log. So 4x. The differentiation of 2x square is 4x. Right? Done. Minus differentiation of 3x is just 3 and ln x remains what it is. Okay, can we simplify this somehow? Let's multiply this 3x by 4x. It becomes 12x square over 2x square minus 3. Yeah, that's a simpler form of this. This 3 can become the coefficient of natural log. So it will become natural log 2x square minus 3 cube over 9x square. We can simplify it further, but I think this is the cleanest form. Next part. Hence, find the approximate change in y when x increases from 2 to 2 plus h. Suppose this is a curve and here we have x equal to 2. They're saying x is changing from 2 to 2 plus h and h is very small. A line which is very, very close to h. Very, very close. See, we can't even differentiate between these two lines. So, if x has gone from 2 to 2 plus h, how much y has changed? It has gone up or down? That's the question. So, our x becomes 2 and change in x will be x plus h minus x, right? So this is the second value minus the first value, x and x will cancel. So h is the change, whatever change, small change it is here, that is h, all right? And x is 2. So we had dy over dx equal to this in the previous part. Same thing we will write here now, but because the change is so small, we call it delta y over delta x, where they are very, very minute changes. So 12x square over 2x square minus 3 minus natural log 2x square minus 3 cube divided by 9x square. And now we know the x and we know delta x, change in x, so we can substitute their values. So delta y equal to delta x is h equal to 12 2 square over 2 square minus 3 minus natural log 2 square minus 3 cube over 9 2 square. So let's do it part by part. Don't put this in a calculator because it becomes very complicated. If one small wrong entry is there, you may get a wrong answer. So 2 square is 4, 4 times 12 is 48. 2 times 2 is 4 times 2 is 8 minus 3 is 5 minus natural log. Again 8 minus 3 is 5 cube over 9 times 4, 36, and it is still delta y over h. H I will bring it to this side on the last step. So 48 divided by 5 will be 9.6 minus natural log 125 over 36 and delta y equal to, and now this h will go and multiply with the numerator. This is, are they asking exact value or decimal value? Approximate change. That means we can express our answer in decimal. Let me do this with my calculator. By the time I do this, I request you to subscribe to my channel and like and share this video with your friends. I'm probably the first person in the world to solve this paper for you guys, and if you subscribe to my channel, I get motivated and make such videos for you in future too. So when I use my calculator, I got delta y equal to 1.3254 h, and we can round it off to 0.133 h. We have another part for this. At an instant when x is 2, same instant, y is increasing at the rate of 4 units per second. Find the corresponding rate of the increase in x. Okay, so we will copy the same differentiation again. Dy over dx is equal to 12x square, okay, over 2x square minus 3. 12x square over 2x square minus 3 minus ln 2x square minus 3 cube over 9x square. Now if you see here, they have introduced a new term per second. That means they have involved time into this. And to involve time, we can forcibly write divided by dt here and divided by dt here, because dt and dt can cancel again. So time is a variable which passes constantly. So we can add it like this. We can divide both up and down by the same time, rate in change in time. And dy over dt, they have written here, y is increasing at a rate of 4 units per second. That means this change is 4. Okay, so this becomes 4 divided by dx over dt, and time is when x is 2. So we will write the same thing again, 12 2 square over, let me do it mentally, 2 square 8 minus 3 5 minus ln 125, that's what we got in previous part also, divided by 9 times 4, 36. And we have everything except for dx over dt, and that's what they're asking. Find the corresponding rate. Whenever they say rate, it is with respect to time, increase in x, which is this. So what happens? I bring dx over dt to the right side. Let me write here. And this whole thing becomes denominator of 4. So we know we got this one as 0.133, right? 4 over 0.133, and if we use our calculators, since I have ignored other digits, it will be almost, dx over dt will be almost 30 units per second. Question 6. The normal to the curve y equal to 1 plus tan 3x at point P. Let's see 1 plus tan 3x. Tan graph has almost this shape. Okay. Suppose this is the point. Okay. And they're saying normal to the curve at P. This is P. That means this will be the normal. Something like this. Okay. His meeting x coordinate is pi by 12 here. Okay, y coordinate will be something else. Okay, meets x-axis at q. So let's say this is x-axis and this is q. The line x equal to 12, x equal to 12 means it will be a vertical line. So this is not y-axis, okay? This is x equal to 12. This line meets x-axis at r. Find the area of PQR. So we need to find the area of this triangle. And we can see it is a right angle triangle. So if we know somehow the base and the height, we get the area, right? The area of a triangle is half base times height. To find the height, we'll have to find the y coordinate of P. So let's find y coordinate of P first. Y equal to, in place of x, we'll put pi by 12. 1 plus tan 3 times pi over 12. 3 and 12 cancels, so it becomes pi by 4. Tan pi by 4 is 1. So y equal to 1 plus 1 equal to 2. So we know the height is 2. Now we need to know what are the coordinates of x, rather especially the x coordinate of this, because y we already know, because it's x-axis, we know that y coordinate is 0. So if we find this, we already know x coordinate of this r, so we can find the base also. So let's find the x coordinate of this. For that we need to find the equation of this normal. Okay, so equation of normal is y minus y1 equal to minus 1 over m x minus x1, where m is the gradient of tangent. Okay, so we have to find gradient of tangent now. So dy over dx is gradient of tangent. So basically we have to differentiate 1 plus tan 3x. Differentiation of 1 is 0, so don't even look at that. Differentiation of tan 3x will be secant square 3x and multiplied by the differentiation of the angle. Angle is 3x. Differentiation of 3x is 3. This is dy over dx and m. When x is pi by 12, what is m? So m will be 3 secant square 3 times pi by 12 with a cancel out, 4 again. Alright. Now, tan secant square is not in our calculator, so we can use the identity m equal to 3, and secant square is 1 plus tan square, and the angle is pi by 4. We know pi by 4, tan pi by 4 is 1, so 1 square will be 1. So 3 times 1 plus 1, 2, which is 6. That's m. Now, we need to complete the equation of the normal. Y minus y1. What is y1? We know it now. At P, y is 2. That's what we found out. So y minus 2 equal to minus 1 over m is known now, 6. X minus, and x coordinate is pi by 12. Now, we are not interested in the equation of the normal. We are interested in the x coordinate of this point Q, where y is 0. So just put y equal to 0 for x-intercept. Q is x-intercept, right? So let's put 0 here and we'll get the x coordinate of this one. So y 0 minus 2 equal to minus 1 over 6 pi minus, x minus pi by 12. 6 multiplies with minus 2, rather minus 6 multiplies. Let's take this minus also, so it becomes positive 12 equal to x minus pi by 12. So what do we get here? Let's bring pi by 12 here. So 12 plus pi by 12 equal to x. So this x coordinate here comes out to be pi by 12 plus 12. This is pi by 12. We know this. The x coordinate here is pi by 12. This became pi by 12 plus 12. So we can find the base now. So base of the triangle will be pi over 12 plus 12. This is what we got for Q, minus pi by 12, which is for R. They cancel out. 12 is the base. And they said find the area of the triangle PQR. So now we can find area of triangle PQR will be half base 12, height 2, 2 and 2 cancel, 12 units square. This is the area of this triangle PQR. Question number 7. A curve y equal to fx is such that the second derivative of this is equal to this, and this exponent is minus 1/3. The curve passes through the point this, coordinates are these. The gradient of the tangent at the same coordinate, yes, is minus 6. Find the equation of the function of the curve. Alright, so let's get started. Second derivative is given to us. D square y over dx square equal to 2 minus 3x to the power minus 1/3. So if we integrate both sides with respect to x, it will be dy over dx, first derivative, and here it's a linear function, so it's good. There's no difficult thing in this. We'll just add 1 to this and divide by the same exponent, but we have to divide by the differentiation of the contents of the bracket also. So minus 3 will be the differentiation of this. Yeah, differentiation of 2 is 0, differentiation of minus 3x is minus 3 divided. All right, let's simplify this by writing c here. Okay, 2 minus 3x to the power minus 1/3 plus 1 will be 2/3 over 2/3 times minus 3. Let's put minus here. So 3 and 3 cancel, and this becomes our dy over dx. Before we proceed, because we want to find the equation of the curve, we have to evaluate this c. And they have given here the tangent, the gradient of the tangent to the curve is minus 6 at this point. So gradient of the tangent is this. In previous question also we said the same thing. So minus 6 is equal to minus 2 minus 3x. X is minus 2 to the power 2/3 over 2 plus c. And we can find c this way. So minus 6, let's no, we can't do that. So minus 6 equal to 2 plus 6, right? This is minus 3 times minus 2 will be plus 6. 2 plus 6 is 8 to the power 2/3 over 2 plus c. Okay, so minus 6 equal to minus 2 plus 6 minus 3 plus times minus 2 is 6. 2/3 over 2 plus c. Okay, so minus 6 equal to minus 8. 8 to the power 2/3 will be first 1/3 of 8. You can use your calculator, okay? I'm doing mentally. 1/3 power of 8 will be 2, and then we square it with this 2. So basically it will be 4 over 2 plus c. So minus 6, and this is minus 2. 4 over 2 is minus 2, becomes here plus 2 equal to c. C comes out to be minus 4. So the equation here, let's write equation of the first derivative will be dy over dx equal to, it was here it was, right? So it will be minus 2 minus 3x to the power 2/3 over 2, and plus c, we got plus c equal to minus 4. Now we will proceed to find the equation of the curve y with respect to dx. We'll integrate both sides and we'll get the equation of the curve. Dx and dx cancel. Integration of dy will be y. That's what we want, which is fx, right? Equal to, let's integrate this one. Minus remains minus. Okay. This is again a linear function with an exponent. So it will become 2 minus 3x to the power 2/3 plus 1 over 2/3 plus 1. There is already a 2 here, right? And we'll multiply this this 2, this 2 is this 2. And we'll multiply further by the differentiation of the content, which is again minus 3. Okay, nothing else. Minus integration of 4x will be 4x, and let's call it d. A constant c I'm not writing because c I used already. I'm using a new constant d. All right, let's try to simplify this. Minus this minus and this minus 3 is minus, will make it positive, so ignore it now. 2 minus 3x to the power 5 over 3 over 2 times this will become 5 over 3, and then we have 3 only because minus has been taken care of, so 3 and 3 cancel, minus 4x plus d. So fx equal to 2 minus 3x to the power 5/3 over 10 plus minus 4x plus d. Okay, now we have to find d, and we know a condition here that this is the point, minus 2, 10.2. That means y is 10.2 when x is minus 2 and y is nothing but fx. So 10.2 equal to 2 minus 3 times minus 2 again to the power 5/3 over 10 minus 4 times minus 2 plus d. Everything is known to us, so we can evaluate it now. 10.2 equal to, this is again 2 plus 6, 8 to the power 5/3 will be 32. By same logic what we did earlier, minus plus rather 8 plus d. So keep d here and everything comes here. 10.2 minus 32 divided by 10 will be 3.2, and this 8 will be minus 8. 10.2 minus 3.2 is 7 minus 8 equal to d, which is minus 1. So our final equation becomes, this was the equation, right? From here we'll take it, fx equal to 2 minus 3x 5 over 3 over 10 minus 4x, and now we got d equal to minus 1. This is the equation of the curve. Let's move on to the next question, which is a vector question. In this question, all lengths are in meters and all times are in seconds. So very easy for us. A particle A is moving in the direction of this one, minus 20, 20. Let's draw it. So minus 20 means it is going to the left 20 units. At the same time, it is going 21 units up, right? And this is the effective vector. Minus 20, 21. This one is the one. Minus 20, 21. All right. Speed is 58, which is meters per second, right? Find the velocity vector. So in this direction, we want to find the vector of the velocity. We have to convert this speed into velocity by giving it a direction. Okay. So we have to first compare the magnitude of this vector with 58. So let's find, do we have some alphabets? No. So let's call it mn. So vector mn is minus 20, 21. Okay. Now I want to find magnitude of mn, which will be square root of minus 20 square plus 21 square. 20 square is 400 and 21 square is 441, which is square root 841. Square root of 841 is 29 units. So this direction, the magnitude of mn is 29 units, but the magnitude of the speed of this particle is 58. So let's compare 58 and 29. 58 divided by 29 equal to 2. That means the velocity vector is twice the vector they have given in which direction it is going, right? Double of the vectors. So the answer will be minus 40, 42. That's the answer. Given that A is initially at point with position vector 5 minus 3. So the initial position is 5 minus 3. This is the coordinate I'm writing because with reference to O, let's say this is O. This is the position vector of the initial point. I converted it to coordinates. We can do that. Now it is going in this direction and its speed is, velocity rather, is minus 40, 42. So they're saying write down the position vector of A where it reaches after time t. So let's say it reaches here. This is A. So this is the velocity speed. So ma vector will be velocity vector minus 40, 42 times t. Velocity times time will be the displacement ma, right? And we know that they are asking us the position vector of A, which is OA, right? What is this equal to? So we know MA vector will be the position vector of the head, which is A, minus position vector of the tail, which is M. And let's bring OM to the left side so that OA is isolated. That's what they are asking us. So MA plus OM equal to OA. And we know both of them now. MA is minus, I can multiply t with each one of them to make it easier, minus 40t plus 42t, right? And OM is the coordinates. It was already given, position vector is 5 minus 3. So 5 minus 3. So finally, what do we get? The position vector of A, it will be, let's add 5 with minus 40t and minus 3 plus 42t. This is the position vector of A. Next one, particle B starts to move such that its position vector at time t, at the same time when particle A is here, so B is somewhere here, okay? I'm just assuming, okay, it may not be correct. Minus 35t plus 4 minus 35t plus 4, 44t minus 2. This is the position vector, right, of B. This is B. Okay. Find the displacement vector AB at time t. So we have to find AB. So from A starting, reaching at B here, this vector we want. So AB, as we did earlier, will be the position vector of the head OB minus position vector of A, OA. OB, they have given here minus 35t plus 4, position vector of B, 44t minus 2 minus OA, we just found OA in previous part, 5 minus 40t minus 3 plus 42t. And they're saying at time t, that means t has to be there, it's not necessary to remove it. Okay, so minus 35 minus 40 will be 5t, let me write later, plus 5t, right? 4 minus 5 is minus 1. Okay. 44t minus 42t is 2t, positive. Minus 2 minus minus 3 is 1. That's simple. We got it. Here is the next part. Hence, find the distance AB. Distance means we are concerned with only magnitude at time t in the form of this. This is the vector we have and we have to find its magnitude. So magnitude of AB will be square of the x component, which is minus 1 plus 5t square plus y component square 2t square. Let's expand them. Square root they want, no problem. So in earlier part of this exam, I gave this identity which is well known to you, hopefully. So let's use this one. Both of them have plus, so we will use plus. Since this has minus, no problem. It will come inside the bracket. It will become minus. So a square plus b square plus 2ab, right? Similarly here, plus a square plus b square plus 2ab, and let's simplify this. 1 square is 1, negative 1 square. This will be 25t square minus 2 times 5 minus 10t plus 1 plus 4t square plus 4t. Can we simplify this now? 25t square and 4t square. 29t square. Minus 10t plus 4t is minus 6t. 1 plus 1 is 2 inside square root. And are they asking us to find? Okay, this is the format they want. And they have one more part of this. Wow, they are trying to challenge us. Find the value of t when the distance AB, which was here, AB, is square root 6. This is equal to square roots, giving your answer to 2 decimal places. So 29t square minus 6t plus 2 square root is equal to square root 6. So square both sides, so square roots are cancelled out. So the quadratic equation we get is 29t square minus 6t plus 2, and let's bring this 6 also to the left side. It becomes minus 6. So 29t square minus 6t minus 4 equal to 0. Okay, 29 times 4 is 116. No, because it's a prime number. We can't get a 6, so factoring will not help in this. So we will use quadratic formula in this. So t equal to minus 6 plus minus a is 29, c is minus 4 over 2 times 29. 36 and 16 times 29. 464 over 58. So 6 plus minus square root 500 over 58. So 6 plus minus 10, 100, right? 100 times 5. 10 square root 5 over 58. So we get two answers. T1 is 6 plus 10 square root 5 over 58. And second answer will be negative. It will be negative because it is 6 is less than 10 square root 5. So we shouldn't even look at this one. Okay, I'm sure it will be a negative time. I'm not calculating this one. This one I can calculate, which will be 0.488992, and we should give our answers in 3 significant figures, so it will be 0.489 seconds because time is in seconds. Question 9a part. The function f is such that fx, the function x, is len of 5x plus 2, x is greater than a, where a is the smallest possible number. Write down the value of a. Okay, it's a log. Every log graph looks like the same. It starts from 0 and crosses x-axis at 1 and it keeps on increasing. Alright, that means x values are always more than 1. This is the graph of y equal to log x. It can be len x also, doesn't matter. They have the same shape. So we can see that this content x is always greater than 0. Similarly here, 5x plus 2 is also has to be greater than 0, then only we can have a graph possible. So they are asking what is the value of a, because x is greater than a. So let's solve this inequality and we get it. 5x is greater than minus 2. X is greater than minus 2 over 5, which is x is greater than minus 0.4. So value of a is minus 2/5 or negative 0.4. Okay, hence find the range of f. So what will this do? This will just shift the graph to the left to negative 0.4 somewhere here, but the shape will remain same. And range means the all possible values of y. So all possible values of y will remain same. That means we can have any real number, because y is going negative to infinity and positive to infinity. We can have any real number value for y. So the range is fx is an element of all real numbers. Okay. Find inverse of x stating its domain. So we have to find the inverse of this function y equal to ln x 5x plus 2. So to find inverse, we first interchange the places of x and y. So let's do that. 5y plus 2, and this y we have to make subject now. For that, this ln must go. Whenever ln is removed, the other side becomes e to the power, right? And let's try to complete it here. E to the power x minus 2 equal to 5y, and y becomes e to the power x minus 2 whole divided by 5, and this is the inverse. F inverse x equal to e to the power x minus 2. Minus 2 is not exponent. Okay, let's write it properly. Minus 2 over 5. That's the inverse. They're saying find the domain also, stating its domain. Whatever is the range of the original function becomes the domain of the inverse. So it will be, in that case it was fx, here it will be just x is an element of real number, because domain is about x, range is about y. Okay, the next one, on the axis, they have given axis in the main exam, which I'm drawing here now. Okay, sketch the graph of fx and f inverse x, stating the exact values of the intercepts of the curves with the coordinate axis. So we know, since we discussed earlier, the line graph will be something like this, and because it is the inverse is always a reflection of this, the inverse will be something like this. But since we have to have exact values, so we have to find those x and y intercepts. So let's start with the first one, ln 5x plus 2. This was our equation for the original function. So let's find its x-intercept first. So for x-intercept, y has to be equal to 0. So let me write here x-intercept. And let's move the graph to the left side to have some space here. Okay, so 0 equal to ln 5x plus 2, right? Natural log of, log of any base, 0 is when the content is 1. So 5x plus 2 has to be equal to 1. That means 5x is equal to 1 minus 2, 5x equal to minus 1, x equal to minus 1/5. So the graph of, suppose this is 1, graph of ln will go through 0.2 here, negative 0.2. This is negative 1. Okay. And we have to find y-intercept now. For y-intercept, x has to be equal to 0. So y equal to y-intercept. Ln 5 times 0, x is 0, plus 2, so ln 2. It is 0.693. Why? So if this is 1, 0.693 will be somewhere here, and now we will join these 2 points and continue them. We know the shape, how will it look like, but it won't go very further than this. No, it will be like this. Now we want to draw the graph of the inverse of this. There's no need to put x equal to 0, y equal to 0 for that. Just reflect this graph on this line, y equal to x, a 45-degree line in this direction. Just reflect this graph onto this line and you'll get it. What it means, we had 0.693 here. So let's say if 1 is here, 0.693 will be here. This will be the point on the inverse. It is reflecting over this line. Now, secondly, we had minus 0.2. Yeah, minus 0.2. Minus 0.2 will be somewhere here. And just join them and they will be reflection. It will pass through this line only, where these are the points, okay? So these are the 4 points we have to join because they are the reflection. This is how it will look like. This is the graph of the inverse f inverse x. That was the graph of the original function fx. The next part for this question is the function g is such that it is equal to x to the power half minus 4 for x is greater than 0. Solve the equation g square x. Whenever they say g square x, it means g of x. Okay, so let's substitute g of x inside gx. So x to the power, let me write it square root x for the sake of simplicity. So gx has been replaced by what it stands for. And now we will substitute in gx. In place of this x, we will put whatever is here. So it becomes gx equal to, okay, we have x to the power half. So square root x minus 4. Square root and inside a square root, it's okay. We'll definitely get some answer because of this. So don't get scared out of this. So in place of x, I wrote square root x minus 4, and power half I wrote as square root minus 4. And they said it is equal to minus 2. So can we square this and square this also so that we get proper numbers? So it is let's rearrange this one. Equal to minus 2 plus 4. This 4 goes with minus 2. So we are left with plus 2. Square root x minus 4. Now we can square both sides to get rid of this first square root. So square root x minus 4 equal to 4. Again, this minus 4, we can shift it to the right side. So square root x equal to 4 plus 4. Okay, so it becomes 8. Square root x is equal to 8, and we square both sides to get rid of this square root. So it becomes x equal to 64. Question number 10a. The first 3 terms of an arithmetic progression AP are these 3. Find the exact values of x where it is an acute angle between 0 and 90, 0 and pi by 2, for which the sum to 20 terms is equal to 390. So we should know the formula for sum to n terms. It is n over 2 2a plus n minus 1 d. Okay, do we have a? Yes, we have a sine 3x. Do we have n? Yes, we have 20. So they said S20 is equal to 390, which will be 20 over 2 times a sine 3x plus n minus 1, which is 20 minus 1. D. Alright, D is not known to us, so we can find D. D is the second term minus first term is D. or third term minus second term will also be d. So let's use a2 is 5 sine 3x, and a1, the first term is sine 3x. So it will be 4 sine 3x. Okay. So 4 sine 3x is d, and done. Okay. Now let's try to solve this equation now. First we can cancel 20 and it becomes 10. So 390 is equal to 10 times 2 sine 3x plus 19 times 4, 76 sine 3x. Okay, we can divide both sides by 10 so that we get rid of this 0. 39 equal to 76 plus 2. Both of them are sine 3x, so we can add them. 78 sine 3x. So divide both sides by 78, and that makes our job easy because it's half. Sine 3x is equal to half. That becomes our equation now. So 3x will be equal to sine inverse half. In my previous videos also I've explained that whenever you have some coefficient in front of x more than 1, always cross the limits. That's what I call it, cross the limits. Since they have said our angle must be between 0 and pi by 2, we will go beyond pi by 2, because less than 0 will give us a negative angle, right? So we'll not go below this, but if there was some plus also, 3x plus something, we would go below 0. But now we will go beyond pi by 2. So let's see, where do we have sine inverse pi by 2? Sine is positive here and here, right? So this angle we have to find. Sine inverse 1 over 2 will give that, and that is pi by 6. So we write pi by 6 here as well as here. So now let's find those angles. First, 3x1 will be equal to pi by 6 itself. We start from 0 and reach to the line here, which is pi by 6. So x1, first answer is divide by 3, pi over 18. Second answer, 3x2 will be this angle. Go to the second line, which is pi minus pi by 6. So 3x2 is equal to 5 pi by 6. So again divide by 3, x2 will be 5 pi over 18. These two are the values of x. That's what they're saying. Find the exact values of x. And since they said exact value, we don't need to change it. Let's move on to the next one. The first three terms of a GP are these. Explain why this progression has a sum to infinity. So for having s infinity, sum to infinity, r should be less than 1. So if I divide 10, what is r by the way? R is a2 divided by a1, or a3 divided by a2, or a4 divided by a3, and so on, right? So we have a1, a2, and a3. So let's take a2 over a1. 10 cos square y over 20 cos y. This is equal to r. So 10 and 20 we can cancel. Cos y will cancel with one of the cos's. So we get simplified form cos y and half in front. Since cos y is always less than 1, right? And half multiplied by number less than 1. Half multiplied by, that's why half multiplied by cos y will also be less than 1. And that's why sum to infinity exists for this GP. Alright, there is one more part of this. Okay, find the value of y where y is in radians between 0 to 2, for which the sum to infinity is 9. Correct to do decimal places. Okay, sum to infinity is 9. So sum to infinity is first term divided by 1 minus r. First term is given to us, which is 20 cos y divided by 1 minus half cos y. Okay, and this is equal to 9. So now this becomes an equation for us. We'll cross multiply to this 9. 20 cos y equal to 9 minus 9 over 2 cos y. Let's put these cos y's together. So it becomes 20 cos y plus 9 over 2 cos y equal to 9. 20 plus 9 over 2 will be 49 over 2 cos y equal to 9. And let's try to complete it here. Multiply this side by 2 over 49, or cross multiply is the same thing, 2 over 49. So they cancel out here, 2 and 2, 49 and 49. Cos y equal to 18 over 49. Y equal to cos inverse 18 over 49. Our answer should be in radians, and it should be between 0 and 2. Let's see what we get. Is positive. Cos will be here positive, right? So between 0 and 2, they're saying there's no point counting till here because it's negative here. So our answer will be in first quadrant. Let's find it out. It's equal to 1.1946, but we'll give 3 significant figures, which is 1.19.